Hello and welcome to the Programming and Coding Basics with VBA, Python, and Java with JavaScript, brought to you by QuadRoot R&D, where we'll cover the basics of programming and coding in 3 languages in just 3 hours. How, you ask? Well, VBA and Python are very easy to learn languages once you understand the concepts of programming. While Java is an intermediate level language, it's easy to pick up once you know the first 2. Now this course is split into 3 parts: an overview, core concepts and applications, and a hands-on exercise section where we'll use all that we've learned in a pseudo AI project. Now, you've obviously reached here because you have some need. Maybe you want to pick up a new skill during this session. Good choice. Or you have an idea that you want to pursue via a program or a website or a mobile app. For that, you will need to know the basics of coding first. Or you have a lot of data that needs processing, and the data could be engineering or health or social or business related. It doesn't matter. Programming can help deal with large amounts of data. Or you're still in school, college, or university, and it's a great choice as it's the future no matter what your specialization. AI is going to dominate the future, and it helps understand its origins. Another reason you might be here is you've embellished your CV and that you can code in VBA, Python, and Java, and your interview is tomorrow. Well, if that's the case, don't worry, I've got you covered. Now, you don't need to be a computer scientist to code. I myself am a mechanical engineer who studied programming in university using Fortran and C. But at work, over the last decade, I've been using VBA, Python, and JavaScript for real-world engineering data analysis applications. Now, this course covers the most used commands that account for 80% of programs with only 20% of the functionality covered, using the Pareto principle or 80-20 rule. And by the end, you will be able to write pretty sophisticated programs short of full interactivity and efficiency, which are intermediate level topics. The first part of this course, we will give an overview of programming and its strategy. Stick with me because it's important to build the foundation first. A lot of other videos on coding dive straight into the tool without giving you a background or a reason why you're doing something, that in the end you're just left confused. Now this course is going to be different, with a solid understanding first of what, then why, and then which programming language, and then move on to how. And it'll solidify it with real-world examples faced at work. Now, if you've dabbled with coding before but haven't been formally educated in university, then I recommend you to go through these concepts with me. If you want to dive straight into the hands-on, then that will be covered in the next part of this course. So, what is programming, and how is it subtly different from coding? Consider your computer as a really dumb child. Well, I'm being harsh. Most children are dumb when they have never done anything before. So each step has to be told to them in detail and precisely. The outcome is only as good as the instructions you give, like a recipe. The more detailed the recipe in terms of portions and timing and methods and procedures, the better the outcome. So think of yourself as a master chef that has to teach your signature recipe for anyone to replicate. So starting with the basics, hardware comprises of the CPU, the memory, the input and output devices, but they all require software to run on. And the software are instructions for the hardware, and especially the CPU, your central processing unit. Now, a set of instructions to be performed is called a program, and it's the most concise statement possible to communicate a process. Now, what's the difference between programming and coding? Well, programming is to coding what knowledge is to language. Coding is just a means to the larger process of programming, which involves computations. Now, what do I mean by computation? It could be a set of instructions to be executed, a set of expressions to be evaluated, a set of rules to be applied, or a set of objects to be arranged, or could be a set of messages to be sent and received. But why programming? The first reason is coding develops structured, introspective, and creative thinking. Steve Jobs once said everyone should learn how to program a computer because it teaches you how to think. And that's so true. When you learn to code, you start thinking deeply about how your brain works. What's your thought process? How do you learn new things? Self-introspect. You take a large complex task, break it down, understand it, and you think, okay, this is what my brain is doing, making calculations. And it ultimately leads to creative thought. What if I did it this way? So you tend to break down every problem into bits and understand it better. You start thinking logically, and this gives rise to more creative solutions. The second reason is programming makes things easier for you. You can turn manual tasks into automated tasks. Now, automation's taking everyone's jobs, they say, and there's a bit of truth to that. Although economists say it creates new jobs, well, not equally. It automates more mundane jobs, but creates fewer sophisticated jobs like programmers, which is why you need to be here. Things get a lot more efficient, what economists call as productivity improvements. More is done for less through coding. I know that myself. I have sometimes automated myself out of a job. Not to the point of getting fired, of course, but I find new things to do. And that's my argument for automation. The task was beneath me to begin with. It's automatable. Now, the third reason is it's everywhere. In your operating system that you're using, in your business or home softwares, your enterprise applications like banking software, or your web or mobile apps on your smartphones, etc. And now the emerging field of Internet of Things, your Roomba. And finally, your brain starts functioning in a way of seeing problems in the light of solutions. Your brain starts to see things differently from a finding solutions point of view. How can I solve this problem? There must be a solution to everything. Maybe not for world peace, but pretty close to that. If somebody out there can say find a way to reduce the cost of renewable energy by programming an efficient system, you remove one more reason for war. Energy, coal, oil, land resources. So there, your Nobel Peace Prize is waiting, guys. Anyway, moving on. Now, before we move on to which programming language, we first need to understand the types of programming languages. So a little bit of history. Now, when programming languages were first invented, we had machine-level languages. Now, this is the computer's native language. Computers can only understand ones and zeros, which is binary, and it can only add, subtract, and compare these numbers. But over time, assembly language was developed, which had some keywords added, like add, subtract, but it was still complex to learn. Hence, higher-level languages were developed and made it more English-like, which we call keywords and syntax, which is the grammar of programming. Now, this made it more accessible to everyone. You didn't have to memorize binary numbers. You could memorize more intuitive commands like input and print. That made things a lot more simpler. So, higher-level languages developed further. The classic higher-level languages were procedural, or structured or sequential. First do this and do that, and so on. But then object-oriented languages were developed, which moved away from the sequential structures and focused more on objects and methods, which can be called anytime, and made it more efficient to code and to execute. So overall, more efficient. And we'll go through that in more detail at the end of the course because it's difficult to grasp without first getting an understanding of procedural language first. Then event-driven languages were developed, which focused on interactivity between the user and the application via events. Every time you click a button, it was an event. Every time you scroll, event. Zoom, event. Type in a text field, event. So now we are heading more towards natural languages in a field called natural language processing, or NLP, where you can speak to a computer and it processes it to higher level language and then to machine level language. And that translation between higher level language and machine language happens by one of two methods: compilation and interpretation. Now, compilation translates the entire program into lower-level machine language, for example, C and Java. Now, what it does is you write the program, it compiles it, chuck, and then it creates an executable, which is then ready to run. So low-level machine languages are faster, so the programs run faster. However, it involves a slower translation speed. Whereas interpreted languages involve some translation line by line during execution. So it translates quicker, but overall the execution speed is slower than compiled languages. And that is the key takeaway. Compiled languages execute faster, but translate slower. However, since you only have to translate the program once, and you can execute the program as many times you want, overall, the process is more efficient as compared to interpreted languages, which have to translate every time you run the program, hence slower. So now we can move on to which programming language. And there are a number of considerations. Obviously, we are going to deal with higher level languages. Now, the first consideration is simplicity. If you just want to interact with some Excel sheets, then VBA is the way to go. Or you can choose Python. If your input data sources are small, VBA is good enough. If you have large data, then Python or Java should be used. It depends on the application. Now, if it's embedded within Microsoft tools or the OS, then VBA is the go-to. If you're dealing with a lot of engineering or scientific or data science problems, then Python has vast libraries. Even MATLAB is appropriate, or R and TensorFlow. If you're looking to build standalone apps, then Java is a great cross-platform programming language. Or you can use Swift and Objective-C for iOS. If you're looking to make web apps, then HTML and CSS make the structure of the page, whereas JavaScript is the engine of the page. And PHP and SQL are used for the backend to deal with databases and securely. You can also learn VB.NET and C#.NET if web is your priority. If you're looking to develop mobile apps, then XML is the structural language that you can use to develop the front end. And Java or Kotlin can be used for the backend, for the core engine, for Android apps, or Swift for iOS apps. If computational efficiency is your primary concern, then you want to use a compiled language which is object-oriented, like Java and C++. If you're particular about a certain company, well, then Google and Facebook use Python, Apple uses Swift or Objective-C, and Microsoft uses VBA, VB.NET, and C#.NET. And then there's cost. If cost is a concern, then you want to go for open source software. Python's open source. Java has an open source version. Or if you have an existing code already, well, then you're constrained to use that language. So this is an infographic I got from Calcio.com, and it pretty much sums up a similar story than from the previous slide. What's interesting to note here is how little C++ is used nowadays, even though C and C++ were the grandmasters of programming. Because of its difficulty, it's hardly used in today's world. For example, it says here, if you want to learn the hard way, then you learn C. But in most cases, Python and Java will suffice. So why have we chosen VBA, Python, and Java? Now, VBA is very easy to learn. If you already have MS Office, close to 1 billion people use Excel, it is estimated. So it's already there. And if you're dealing with Excel spreadsheets and you want to do some automation, then learning how to write macros would be beneficial. It's a high-level language, of course, and it's embeddable in your spreadsheets. It's a procedural language, and it's event-driven. It can detect clicks and scrolls. It's used for the development of MS Windows OS as well as MS Office. And as I mentioned earlier, it's easy to develop macros for Excel tools and Word. Python, on the other hand, is easy to learn. It's open source. It's a higher level language, of course. It's embeddable. It's object-oriented, so more efficient. And you can deal with large data sets. It's portable cross-platform. It's extensible in C and C++. It's an interpreted language, so it runs slower than C++ and Java. But it has extensive libraries for scientific, statistics, and ML applications, where ML here is machine learning. And Java and JavaScript, Java is used, as I mentioned, for standalone apps and Android apps, whereas JavaScript is used for web pages, and both these will be the engine of those apps. They're at an intermediate level, not so easy to pick up, but once you know the first two, you'll be able to understand what's going on. It's open source. They have open source versions. It's a high-level language, of course. It's embeddable by APIs in Internet of Things devices. It's object-oriented. It's an event-driven language. It's portable cross-platform. It's also a compile language, so it combines the advantages of the first two languages. And you can build beautiful standalone applications and use for web and mobile app development. As you can see in the ranking below, Python is on top, and it has applications in the web and standalone desktops. Java has applications in the web, mobile apps, and standalone software, and JavaScript in web design and mobile app software. So with these three languages as well as VBA, you're pretty much covered for all kinds of applications. And with that, we end with the overview. And in the next class, we're going to talk about the how from a very top level and then go into detail as we progress with this course. So if you've reached this far, don't forget to like the video. I'll wait for it. Great. And subscribe so that you receive updates about the next video. And don't forget to share with your friends who are interested in learning to program. Comment if you want. Ask me a question. Suggest which language you would like to learn in the future. And I'll see you in the next class.